Hi, I'm Nick Tune, and I'm the CEO and co-founder of OptimiseAi, and we're a spin-out from Cardiff University. And I'm going to talk to you about how we are unlocking net zero and ESG targets with the use of AI and digital twins. And the problem that we are targeting is the massive glut of buildings in the UK that are lower than an EPC of a B. And we have a target that all buildings need to get to EPC B by 2030. And yet we're a long, long, long way off. And partly the reason for that is just the lack of information about these buildings. We don't have the data about how they're performing. And often when there is data, it's fragmented, it's siloed, and people just don't understand what to do with it. And that leads to us relying on consultants to basically tell us what the data means and how to improve. Well, the amount of consultants that's available and the time it takes to do that is prohibitive to take all these 1.2 million buildings up to more energy efficient standards. And this can be demonstrated here within our EPC map of the UK that shows every EPC of non-domestic buildings. And here I'll zoom right into the centre of London, into Mayfair, and you can just see in some of the most expensive properties in the UK, what percent of them are EPCs that are E to G, for instance, the worst energy performing and carbon performing, and the Cs and Ds. So we've got a huge job to be able to take these buildings and make them more energy efficient. And some technology has got to come in because we need a fundamental shift. And we believe that fundamental shift is the use of artificial intelligence and digital twins. And that can be shown here, where we've looked at time and motion studies before of how long it's taken to do an energy audit, make an energy model, get the data you need, come up with the reports to basically tell the client how to save energy. Where by tapping into the smart meter directly and getting some basic information from the client, we've been able to get this down to literally 10 minutes. And let me show you how. Here, we'll look at the Roehampton Club, where we took some basic information about their buildings, we connected to their smart meters, and you can see from our tool how much energy they're using, how much money they're spending, how much carbon they're emitting, and we have a breakdown of costs, so we can see live cost data here, we can see live carbon emission data, and then we can even go to diagnose to see how the building's comparing against the UK average of the size and type, how it would compare against meeting the new UK zero carbon targets. We can appraise what this EPC is and what it actually is performing like in real life. We can disaggregate to see where the carbon emissions are coming from or the energy. We can even look at the energy tariffs to see which are better energy tariffs that are available for that customer. And then we go to look at what are the energy saving measures that can actually be implemented to make improvements, and how much energy, how much carbon each one will save. And we can even put in costs to do a return on investment calculations and actually plan that route to net zero. And then finally, we can timestamp when a measure has been implemented and actually validate the amount of savings in energy and carbon, for instance, and pounds that have actually been made. And all that can be done literally within a 10-minute time frame. And it's how we do it. We do it by connecting up the data from a smart meter with a simulated energy model of how a building should perform, with a big data model where we've trained our machine learning across data for millions of buildings, and we're triangulating between the actual data, the simulation, and the big data model to understand how the building should perform and to improve it. And we can even go to the much more granular level. Here you can see Bristol Temple Meads, where we can look at the total performance of the site, but then break it right down to individual rooms and zones within the building, as I will show here. And then we can even bring in IoT to get things like the amount of motion, so know when people are there, carbon dioxide levels, and we can track the energy performance right down to a granular level. And we can track, for instance, what the difference is between the predicted and the actual, to be able to see when a change has happened and to be able to track actual benefits and make that done in a real-time live basis, and then deliver it in practice. As you can see an example here where we're doing dynamic optimization of lighting on a platform, because we know what the lux level should be on the platform, we know the train timetable data, And we've got live information of when people are on the platform, so we can produce an actual schedule that is automatically controlling the lighting, for instance, on that platform. Now, we're just not delivering that in train stations, we're delivering it across the whole spectrum, and we're doing airports. As you can see here, we're doing rail, but we're doing offices, we're working with big energy providers and education establishments, and now we're going wider to other ESG areas, such as with water for their business customers, and housing, and even dealing with air quality and damp and mold issues. We're busy now doing our next fundraise, and we'd love you to get involved with us. Thank you.